Friends, today we will discuss chemical earthing. Chemical earthing. What are the fillings, chemical components? We will discuss their properties. First one is bentonite. Second is marconite. We will discuss about the marconite. Marconite, it is an electrically conductive aggregate and innovative earthing technology. We will discuss. It is electrically conductive aggregate. So whenever soil resistivity is very high, we use chemical compounds or chemical earthings. So many components like chemical components like bentonite, marconite are used for the better earth resistance in earthing grid resistance. So this bentonite has a 5 years life cycle, and this marconite has a 50 years life cycle. So this is costly one. Marconite is costly one. We will discuss some details about the marconite. How you will introduce. In the past, engineers relied on technology related to the generally available minerals to design the earthing system for various applications like power stations, buildings, railways, industries, complexes, water and gas plants. These earthing systems require presence of water to maintain the moisture and earthing resistance. In 19th century, marconite was specially developed to meet the requirement of the type of earthing applications, but without the need of water. It doesn't require water. It is electrically conductive black granule used as a backfill material to enhance the effectiveness of the earth to achieve the durable, stable and low resistance performance. So water requirement is 0. Water requirement 0. No water is required. It is electrically conductive and black granular. To achieve durable, stable and low resistance performance, earthing solutions for all type of soils and difficult ground conditions like high soil resistivity. This is a main criteria. Whenever there is a high soil resistivity, means hard rock, we use the chemical earthing. Marconite conducts electricity much as the same way as the metals through the movement of the electrons. It does not require water to conduct electricity and is not affected by dryness like other ionic based earthing materials such as bentonite, charcoal, etc., which always require the presence of the effectiveness electrolyte, else they dry out and do not conduct electricity. Marconite conductive concrete is one of the most suitable minerals for the treatment of soil. Electrical engineers have been using it to tackle the toughest soil conditions so as to achieve the satisfactory earthing solutions throughout the world over the 50 years. Silent features. What are the features we will discuss now? Features of marconite. First one is fixed carbon. It's 98.5%. Second is ash, volatile and water. Ash, volatile water, it's 1.5%. Third one, sulfur content 1.5% maximum. Fourth, what is size grading 10% below 0.1 mm, 5% above 3.15 mm, and 85% between 0.1 to 3.15 mm. So its grading size we have discussed. Thermal stability. Thermal stability is between 10%, minus 10% and plus 60% of the ambient temperature. So this is the thermal stability. It is minus 10% and plus 60% of the ambient temperature, whatever ambient temperature it has. Then ultra low resistivity, its property has ultra low resistivity. How this is achieved by this marconite? Resistivity of the marconite is 0.001 micro ohm meter. This is the resistivity of the marconite. When mixed with the Portland cement, it is still 0.04. If mixed with Portland cement, it is 0.04 ohm meter. So this is the resistivity, which is significantly lower than the other earthing materials. Marconite aggregate 0.001, marconite aggregate has resistivity of 0.001 ohm meter. Then normal aggregate has 30 to 90 ohm meter. Okay, so marconite conducting concrete, it has 0.01. Concrete, when mixed with the concrete, it has 0.04 ohm meter. And where the bentonite has 3 ohm meter. Versatile. Marconite is suitable for all types of soil ground conditions. It becomes a permanent soil structure and does not shrink to get washed away. It does not require moisture at all. It performs very well in dry soil, hottest climate conditions. It performs in dry soil and hottest soil condition. Give performance under dry soil condition. It performs well in dry soil condition and hottest climatic condition. Consistent performance. Once installed marconite based earthing system, it gives consistent performance of and earthing resistance value remains in same in the year or very very low significant variation. So there is no variation in the resistivity or resistance. Contact area, solid surface provides larger surface area for dissipation, thus dissipates current faster. Contact area, solid structure provides larger surface area for dissipation, thus dissipates current faster. Okay. Chemically inert, its pH value is within the neutral range. pH is neutral. pH is neutral. Non-corrosive, it's non-corrosive. Marconite does not corrode steel or copper conductor or attract cement structures. It may be noted the effect of DC current spreads to the radius of 30 to 50 kilometers from the earth electrode stations. When DC current backflows return earth is used to transmit the power in HVDC, which accelerates the corrosion of earth electrodes, pipes, pipelines and other metallic structures, objects. So DC, whenever there is a return backflow of DC current from transformer saturation or earth return, it is used to transmit the power in HVDC, which accelerates the corrosion in a earth electrode pipe. In this condition, in HVDC substations, we can use marconite, which is opposing to the corrosion. Pipelines and other metallic objects within its vicinity. Okay, so applications we can say. Application HVDC substations. Okay. GIS equipment uses earth metal screens and enclosure around the individual phases, conductors and residual AC flows continuously via earthing system. This causes additional corrosion of the earth electrode. There criteria for the corrosion in the earthing system, criteria where corrosion is possible, there we can use marconite. Now HVDC is one substation where DC return current causes the corrosion of the earth electrode. Also GIS equipments uses earth metal screens enclosures around the individual phase conductors, and a residual AC current flows continuously via earthing system. This causes additional corrosion of the earthing conductor. Here also we can use marconite. Encapsulated conductors are the best solutions to protect such corrosions. In GIS there are some metallic enclosures are there for the breaker and all the equipments. So individual phase currents and residual current continuously flows via earthing. This causes additional corrosion. Okay, this is one important point in GIS substations. Life. Marconite has a 50 years of life. 50 years of life cycle. Okay. Maintenance, absolutely maintenance free and does not need water for life. No need to remove, replace and recharge it in order to maintain the desired earthing resistance. Environment friendly. Marconite does not leach and pollute the water channels like other earthing systems. Use of the marconite is also saves trees from burning to get the charcoal. No environmental hazard. Marconite does not pose any environmental hazard for the future generations, even if the completion of its life as it disintegrates with the soil like any other concrete structure. No environmental hazard. It is disintegrated from the soil. Cost effective, especially high resistivity soil, sandy and waterlogged areas. Low ownership cost. Long and maintenance free life. of marconite based earthing system makes it cost lowest among all the earthing systems. Easy to install, requires only borehole or trench to install, no space constraint. GIS occupies only 15 to 25% of area occupied by the equivalent AIS. Hence, it becomes difficult to achieve the required level of earth resistance in small areas. Marconite encapsulated driven rods are the best solution to achieve the low resistance value in GIS substations. Improvement factors. In practice, improvement of 40 to 60% is generally achieved by the marconite conductive concrete. Refer 13 okay, we will discuss that later. Compressive strength. Marconite concrete, once it is set, displays a greater compression strength than 25 concrete, grade 25 concrete, and it becomes significantly greater than the period over the time. Metal conductor saving. Designing the earth grid, diameter of conductor is designed oversized to withstand corrosion. So marconite encapsulated rods solve this problem and also save the steel conductor to count. Provision of over designing of the earthing conductor is required in absence of the corrosion. Increased surface area of marconite embedded rods reduces the overall requirement of the earth grid's horizontal conductor, which otherwise would be required if bare rod are used. Technical reference. IS 3043 electrode enclosed in low resistivity material conducting concrete, page number 71 and 73. Technical reference we have taken from IS 3043 BS 7430. Here also conducting concrete, page number 74, it is mentioned. So IS 3043 is the reference. IS BS is there, BS 7430 is there. Here conducting concretes are mentioned on page 71, 73, and here page 74, 76, and IEEE 80 is also there. Concrete encased electrodes, page number 68, it is also mentioned over here. Engineer's handbook and other so many references we have there. Now what are the test reports? Resistivity aggregate, which is we have discussed. What tests are to be taken? Short current electrode test is also carried out. Copper rod, aluminum rod, MS rod. Earth resistance value is also calculated. Compressive strength cube is calculated. Chemical tests. Marconite aggregate was tested by Mucot laboratory. So the chemical tests also can be carried out. CVIP technical report 78 1991, concrete encased electrodes and use of the steel structure earthing department. So CVIP standard is also referred. Practical aspects of using marconite. So some of the information we have just discussed here, and in next lecture we will discuss the remaining part.